So our today's speakers, so first of all, thank you so much for being here, for coming to the seminar. Our today's speaker is Henry Aray. Henry is Professor Titular, so Associate Professor at the University of Granada. His research interests mostly include empirical macroeconomics, and he's using a lot of spatial data, some regional data in his research most recently. Two very interesting facts about Henry. So, first of all, before his academic career, he worked at the Central Bank of Venezuela. And I think what's also very interesting that it's not his first time presenting here. So he doesn't remember exactly where he was presenting, but he was presenting here at Universidad Rovira i Virgili in 2001 as a PhD student. So it was actually his first presentation ever during his academic career that he presented here at our university. So Henry, I'm very happy to have you again here at the University of Rovira i Virgili. And yeah, the stage is yours.
Okay,
Thanks so much.
thank you. Okay, yes, thank you for the invitation. I'm very glad to be here. It's true. Well, my first conference was here at the University of Red. When I was a PhD student, my first presentation, I was very nervous. The presentation, I remember exactly the moment, was here at the Applied Economic Meeting in 2001. Applied Economic Meeting. I remember even the session chair that was Marian Camarero from the University of Castellón. And I remember she said, el chaval estaba muy nervioso. She said, the guy was very nervous. Yes, that's true. I was very nervous. Okay, well, I am a little nervous today also, but anyway. Okay, well, this is a paper. I am, as I said, David said, from the University of Granada. This is a paper with Jorge Martinez Vázquez from Georgia State University. Well, the paper, maybe the title is very ambitious, but well, I think it fits with the content. Okay. Well, the motivation of this is basically, well, we know that there is a paper, seminar paper, as our 1989. This tests the relationship between public capital, stock, and economic growth. This is the most important thing of this paper, that it triggers a very active research on the relationship between public capital, stock, and economic growth. And you know, basically because public capital is a crucial input for competitive and productivity gains. But even this paper, that's our warning in his paper about the important role of public capital stock on total factor productivity, a slowdown in the U.S. economy in the 70s and 80s. Most developed countries have been experiencing stagnation in the public capitals. For instance, this is a plot with public capital stock per capita for the USA, some European countries, China and Russia. And as you can see, for instance, this is the States. As you can notice, most of the developed countries have in the last year, at the end of the sample, this is 2018 or something like that, 19, okay? They are experiencing stagnation in public capital stock per capita. Instead, for instance, China has recently are performing very, very well in terms of this. So, and even overpassing, for instance, countries like United Kingdom, similar to Spain, okay? And Russia also shows a good performance, but not so good as China. So, developed countries are aware of this situation, and some of them have established plans to overcome this situation. Okay? Well, but this paper, we know, in general, the thing of public capital is, okay, the issue with public capital, okay, we would like, or the objective is to get an optimal or adequate level of public capital stock in a country, and Other issue is the right and fair geographical distribution. Okay? And this article focuses on the second issue, in the right and fair geographical distribution of public capitalism. Okay? So, contribution of this literature is limited. We have theoretical literature that basically has focused on the efficiency equity trade-off. Okay, that basically is they look at the parameter of social welfare function. Okay, and the empirical literature have been very active proposing reasonable criteria for the allocation of public investment across regions, province. However, the problem is that without not theoretical support. Basically, I would like to estimate this equation. It's okay, it's nice. They get interesting results, but not theoretical support for the model, the equation, the estimate. So this article tries to bridge the theoretical and empirical literature, okay, on this topic. We have inspired story in the new economic geography and economic growth literature that consider the spatial dimension. Okay, so what we do, this paper has two parts: the theoretical part to bridge the theoretical and empirical literature and the empirical implementation. So in the theoretical part, what we do is we propose a theoretical framework in which we have a social planet that maximizes a social welfare function to allocate, to distribute public spending, public investment, sorry, that consider not only output per capita, that this is the traditional way to consider just output per capita, but also, this is what one of the new of this paper, we also consider output per surface of output density. Okay? So this is basically the social welfare function has two arguments: the typical output per capita and output density. Okay? This social welfare function is constrained by the production function. Okay, we use CES function for both social welfare and production function for the economy. In addition, this maximization problem is constrained by the law of motion of public capital. Okay, we assume that the public capital accumulate according to a non-linear function that allows to capture marginal diminishing return of public capital investment. Okay. So this is a very simple model. It's just a maximization problem, and the idea is to get an equation, a tractable equation, to be used for empirical implementation. This is the idea. Okay. We use that data of Spain for the empirical implementation, and our main findings basically are both of the coefficients of the economic criteria suggested by the empirical literature to allocate public investment are significant, okay, and have the expected signs according to the model. Okay. Output density should not be overlooked in this kind of problem according to our empirical result, because it has a very important weight in the social welfare function. And there is a very robust across estimation method, different alternative dependent variables, and the inclusion of additional variables. Okay, this is just a review of the literature, because this literature dates to the 50s, after the Second World War. The European government needs guide for allocation of public investment, so the first scholar contribution in the 50s, that at the beginning they started just using the objective was to maximize the output, which it makes sense. You have to recover the economy, just like maximize the output, the national output. After that, after this was overcome, let's go to the move to per capita income, and in the 60 basically started using more a social welfare function as a object, and nowadays the theoretical contribution depart from a social welfare function. Okay, from a regular, but this early literature focus on national perspective. Regional perspective, distribution of public investment across jurisdiction is in the 60s. To the best of our knowledge, the first paper dealing with this was Stewart published in Land Economics, and after in 1966, after that, after him, Mera contributed also the literature, and in 1987 there is a paper that for us is our reference paper, published in American Economic Review, in which these guys propose a theoretical model with a social welfare function to allocate public funds for distributing services, safety services across the neighborhood. It's just I think that it was Baltimore the city for this for the empirical implementation. And in addition, Caminal and De La Fuente have all proposed theoretical models using social welfare function to distribute public investment across region. But these two papers are more theoretical. In fact, the empirical implementation is very limited. Okay, so we have this. On the one hand, we have the thing of theoretical literature that is okay, but the empirical implementation are limited. And on the other hand, we have the empirical literature. The empirical literature, as I said, have been very active proposing measure, criteria for distribution of public investment. For instance, efficiency. This is the and also of course inspired or based on the theoretical literature of course efficiency, but in the empirical implementation, what variable do we need for capturing efficiency? Well, the typical measure that they use is just the output per stock of public capital. Okay, inspire basically production function, the marginal productivity of public capital stock, and in empirical implementation, we can use what they suggest to use just the output per public capital stock. In empirical implementation, this the correlationship between public investment, any measure of public investment, and this indicator must be positive. Okay, this is the expected side. The other criteria, typical criteria, redistribution. Basically, redistribution is the empirical literature use as is natural the GDP per capita. GDP per capita or GDP per worker, depending on the available information. Okay. The expected sign in empirical implementation is negative. Okay, just to promote this catching up between logic, region, and region. Okay. In addition, other authors are proposing equity. Basically, this is just empirical. This is like, okay, what's variable is to be interesting? Well, let's propose equity. And equity is just public capital stock divided by the units of surface, density of public capital. Okay? De La Fuente proposed an interesting criteria that they call neutrality. And basically, neutrality has the same idea of, the neutrality captures the same idea of equity, because as you notice, it's just their weight mean between the public capital stock per capita and density of public capital stock. So whenever gamma equal 0, we have the equity. Both the expected sign of this in empirical implementation, the expected sign of this variable should be is negative. Okay. And finally, other author, for instance, Rodriguez Bose, Castel and Soleoyer, propose the population density. Sorry, Castel and Soleoyer is not here. So just Rodriguez Bose. Density, population density. Basic population density is the idea is to capture agglomeration and congestion. Sorry, this is the. In that case, if you if the objective is to capture agglomeration and congestion, sorry, the expected sign should be positive. But also, this could be negative, the expected sign, if the planner is interested in favor isolated regions that are with very low population, but they are very isolated. So when you revise the empirical literature, some of them, the expected sign is positive, and they argue the fact of agglomeration and congestion. But in other paper, they say the expected sign is negative because isolated jurisdiction needs more investment because the cost of create infrastructure in isolated region is more expensive, so the sign should be negative. Okay? Well, with this information,
sorry, just a clarification, but congestion is bad, right? Agglomeration is fine, but congestion should be negative, right?
Well, see, no, I mean, but apart from the idea that agglomeration comes along with, sorry, or congestion comes along agglomeration. No?
I would say that up to a certain point, you have economies of agglomeration can be positive, but up to a certain point, if there is congestion, then...
No, but this means that if you have a very low density area, no, a population with high area, sorry, with high population density, it's agglomerated, but also it's congested, no? No, this is just the idea. No, just for that. This is just for that reason I say it's capture agglomeration and congestion, just because this is very populated area. Okay. Okay. So this is the model. As I said, we use both set function for the production function. So we have the production function with private capital, let's say, human capital, workers, and worker and public capital stock. 3 inputs, okay? This omega is the substitution parameter, and alpha are the shares parameter. Okay, the law of motion of public capital stock is inspiring Lucas and taking the idea of this guy from this paper. And what we propose this nonlinear function, okay? In this function, we have this stock of public capital stock is function of the previous capital stock in the previous period, sorry. And we assume that there are 2 agents providing investment. Okay? For the central government, for instance, C is the public investment in jurisdiction, J in period T made by the central government. Okay? And R is the public investment in the same period, in the same jurisdiction made by any other agent. Okay? So the public capital accumulates, okay, because we have 2 investment agents. Okay? We are going to concentrate on the central government. Okay? We solve the problem for the central government. Okay? Okay, we have the social, we introduce a social welfare function. Okay, this is the social welfare function proposed by Berman and Gray. Okay, as I said, they use GDP per capita as an argument. Okay, rho is the parameter, aversion parameter to output inequality, and it's the population in the jurisdiction, and this V is a variable to address equal versus unequal concern. I will refer to this later. Let's concentrate just in the social welfare function, the parameter. According to this social welfare function, rho should be in this between minus infinity and 1. Okay, if rho tends to infinity, the planet only concerns itself with equity, and if rho tends equal to 1, the planet only concerns itself with the total output. Okay, it's not basically as long as rho go from 1 to negative and infinite, the planet is more concerned about redistribution. If rho equal 1, no concern. Basically, whenever rho is lower than 1, whenever the central government has a rho lower than 1, is concerned about redistribution. Okay, as I said, this variable capture equal concern, equal versus unequal concern. For instance, we can assume JT is equal to BT. That means all the jurisdiction has the same weight. Basically, this variable is basically to weight the region of the jurisdiction. Okay, you can assume that all have the same weight, or we can use different weight for this. For instance, Berman and Craig and introduced or collected in this V, for instance, political variables. Okay? Okay. What? Sorry. Okay. Oh.
No?
Okay.
Yeah.
Okay, so this is, as I said, this is the social welfare function proposed by Berman and Craig. As I said, we have inspired on the new economic geography that highlight the advantage of the spatial agglomeration of input for generating inclusive return and positive spillover and confirm, for instance. In addition, there is a paper published in Science that say that more sophisticated products are located in the siliconetic areas, whereas less sophisticated products are produced in less peripheral areas. Okay? In addition, regarding the economic growth literature, we had a seminar paper of Ciccone and Hall that said that has the result that density of economic activity is positively related to labor productivity and total factor productivity. In building on the idea of Ciccone and Hall, Davis et al. Got the result that output density is positively related to per capita consumption.
Can you put the microphone a bit up? Sorry.
Now it's okay?
It's okay? No.
Está apagado.
Puede ser que la pila se escapó.
¿Todavía? Ahora sí.
Ahora sí.
No estaba pasado totalmente el botoncito
Sí.
hasta el final.
Bueno.
Se quedó así como en un punto que no terminó de encenderse. I'm so sorry. I'm sorry, I was speaking Spanish. Okay. Well, so with this literature, we say, okay, it seems to be that density is important for spillover, or in international trade, for instance, on economic growth literature, according to a paper Ciccone and Hall, density of economic activity is important to generate, to affect positively labor productivity and total factor productivity, etc. So, based on this literature, we extend we extended the social welfare function proposed by Berman and Cry, and we introduced their output density in this social welfare function. Okay? And this social welfare function nests the Berman and Cry function whenever eta equals 0. Whenever eta equals 0, we have the social welfare function, a function proposed by Berman and Cry. If eta equals 1, we have a model, social welfare function in which the planet only cares about output density in the spirit of Chicote and Hart. Well, we solve the model, basically maximize this social welfare function, subject to our constraints that are, remember, the production function, the law of motion of public capital stock, and exogenous resource constraint. Okay, this is basically the exogenous resource constraint means that the total amount of investment allocated to the region, the summatory, must be equal a particular exogenous factor. Okay, this is exogenous. It can be endogenous, but we follow Berman and Cry that assume this case. Okay, of course this is the solution of the model.
Excuse me, you are assuming that the public investment made by your other agents is endogenous?
Well, we are, yes, because in this model we are just concentrating on the central government. Okay, central government. Yes, this is the next step. This will be the next step.
Yes.
But in this paper, we want just to bridge empirical and theoretical literature. And we are aware of that any referee, any person that deals with this literature or knows at least something about this literature will immediately think about, okay, but we have the other agent also providing public investment, and there is this interaction. Okay, that's true. But in this paper, we just start with, okay, let's just to bridge empirical and theoretical literature. So we solve the model for the central government, okay, and we assume that the regional government investment is exogenous. Okay, so we solve the model. Okay, the idea was solve the model and remember, the objective is to get a tractable equation for empirical implementation, collecting the criteria suggested by the empirical literature. Okay? So this is the equation that we got finally after solving the model, rearranging, doing some, basically rearranging, sorry, and we get this equation. Notice, this equation has all the criteria suggested by the empirical literature. In the left-hand side we have, notice this is the investment made by the central government as a share of the total public capital stock. Okay, this will be our endogenous variable, independent variable, and on the right-hand side we have all the criteria. Notice, this is the efficiency criteria. Okay, this is the redistribution criteria, GDP per capita. This is the neutrality criteria proposed by De La Fuente, Ángel de la Fuente. This is the population density, all the criteria suggested by the relevant empirical literature. Okay. And in addition, we got in our model 2 additional criteria related to convergence, because this is the GDP per capita of the jurisdiction divided the GDP per capita of the country. Okay, so this can be called convergence, and this other new criteria that is related to the economic side, because this is the GDP divided by total GDP. Okay.
Excuse me, what is lambda?
Lambda. Okay, lambda. Lambda is there's a lot of problem. When we solve the model, lambda is the Lagrange multiplier. Lambda is the Lagrange multiplier of solving the model. Okay? So, the first term, this term, collect all parameter, parameter. This is the parameter of the low motion public capital stock. This is the parameter of the production function, and this is, as I said, this is lambda, is the Lagrange multiplier, and this A is a constant that is equal to some parameters. Okay. Solution. No, it's positive.
But when you solve the optimization problem, okay, if you can obtain lambda, lambda will depend on the other variables. No?
But lambda is assumed to be exogenous.
No, it's a multiplier, it's Lagrange multiplier.
Yeah.
But it's not exogenous.
No, but I mean, this is this is the first of the condition. Okay, from the first of the condition, I get this equation.
Yes.
Okay, so it said, okay, yeah, I see what you said.
The idea is if you solve lambda, will depend on
Yeah.
the other variables, and maybe you can obtain another expression.
Okay.
Consider the expression of the lambda that depends on the other.
Okay. This is interesting because I could think about that, but basically I follow the methodology of Berman and Craig and Castel and Soler-Ogier that basically do similar procedures to get this
If
equation.
it is exogenous, you should be sure that it's exogenous.
Exactly.
Maybe.
Yes.
because of the
I just
function.
follow like why they solve this with the first of the condition. I just get this tractable equation to estimate. But it's true what you said, of course. Okay, so this is our objective, to get an equation collecting all the economic criteria suggested by the relevant empirical literature. As you can notice, okay, as I said, efficiency. I noticed the expected sign should be positive, as expected in the empirical literature, whenever we have this constraint, which is okay. Redistribution criteria should be lower than 1 if the central planner is inequality averse. If this rho is negative, is what empirical literature expects in general. Okay, the sign of this criteria, the neutrality criteria, should be negative as expected in the empirical literature. The special infrastructure needs criterion, okay, this could be also positive or negative depending on rho. If rho is negative, this will be negative. If rho is positive, it will be positive. Okay, and the convergence criteria is expected to be negative and can be also negative and equal 1, but we said negative. And the economic side criteria, the sign should be positive. Okay. So this is our Benmar's equation that we use from the empirical implementation. Okay, in empirical implementation, we have to introduce or to make some assumptions to estimate this. First, introduce a random term, and this, in addition, we follow Castel and Soler-Ogier that they argue that when a planner plans the distribution or the allocation of public investment, the most recent information that they have is from the previous period. Okay, let's distribute it, but I don't have information. Okay, from this period I don't have information, but I have information from the previous period. So what we do is to introduce the right-hand variable in a lag. Consider a lag. Okay, this is based, as I said, we take this idea from Castel and Soler-Ogier, and incidentally, this is okay because this allows to avoid endogeneity problems. Okay. Okay. In addition, we have multicollinearity problems because there are a lot of variables that are constructed using basically the same variable. So we have perfect multicollinearity programs. So we rearrange, rewrite the model, and we got this final expression. It's true that we have, in this final expression, we don't have this criterion. Okay? When we rewrite the equation, we have this final equation, and this is the final equation that we are going to study. But even though we remove, we could say that, okay, we remove this, we can still obtain the parameter eta implicitly from the estimation. Okay? So, we estimate, we get the log of this equation and estimate this. And this is basically this. Taking log of the previous expression, we estimate this equation. Notice we have to check the efficiency criteria, expected to be positive. Redistribution criterion now is expected to be negative, because when we rewrite the model, this parameter is rho -1, so it's expected to be negative without, it's clear the model is negative, okay? Beta 3, that is parameter for capturing this, the variable capturing special infrastructure need, is expected to be negative from, okay, expected to be negative, beta 4 the same, negative, and beta 5 positive, okay? And we estimate using we use panel data, okay, with fixed effects, individual regional effects, and time effects, okay? Okay, here we have we summarize the expected sign according to the model, okay? As I said, we can obtain the explicit estimate and the standard error of the parameter eta for the neutrality criterion, okay? Okay, use data, as I said, from Spanish autonomous communities, during the period 1986 to 2010. Well, I think that most of you know the data, the database. EVA, everybody, INE, etc., etc. Okay, and we estimate. This is our first result. Here I copied this basically to remember the expected sign of our model. Okay, efficiency expected positive. We can check. Okay, this is estimation. This estimation is, as I said, with fixed effects. Here we have the Hausmann test, all the tests, heteroscedasticity tests, autocorrelation, serial autocorrelation text, cross-sectional dependence text, etc., etc. So we estimate using panel corrected standard error, and these two columns are using panel corrected standard errors, and the other two columns are feasible general least support. Okay, so we check the result. We have as expected positive and significant for the efficiency criterion, positive significant coefficient for the significant criterion, negative as expected for the redistribution criterion, in line with the model, also negative coefficient for the special needs criterion. The convergence criterion also expected negative, and also we test the hypothesis that this coefficient, according to the model, could be equal or is equal to 1. And we test this hypothesis, this beta 4, notice the hypothesis. Let's test that it's equal to 1, and it's not rejected, okay, in most of the cases, basically. And the last criterion is economic side. This is positive in some cases, for instance like this, but anyway, it's not significant in any case, okay? So 4 out of 5 of our criteria are significant, our coefficients are significant. In addition, as I said, we can get the implicit estimation of the neutrality criteria, the eta, and we show that this is as expected. This is positive, but in the equation this should be negative, so it's according to the model. And the interesting estimation of this eta is not only because to provide evidence of this criteria, but also because remember that this eta is the parameter that weights the social welfare function. Okay, that give us the weights in the social welfare function. So according to this, the output density weighs about 70% in the social welfare function. Okay. We have additional results. This is our benchmark equation that whose dependent variable is, remember, the investment as a share of the public capital stock. But in the empirical literature, we can see other dependent variables. For instance, it's very common to see, of course, investment per capita. Okay? Public investment per capita. So this is what we do here. We rewrite our benchmark equation and rewrite the model to get this. This is the equation from that we get from the maximization problem. Incorporating the random pair and lagging the dependent variable one period, we get this expression. But now the dependent variable is the public investment. Sorry. Let's see. Sorry. Okay, sorry. This is public investment per capita. Okay, and again we proceed similar to the in the previous case. Okay, but now we have some change. Notice, according to our model, we still have beta 1 is positive, provide this, but notice beta 2. This is the parameter. Beta 2 is the parameter for redistribution. According to our model, is just lower than 1. That means that it can be positive in the estimation. The constraint according to rewriting the model like this shows that this beta 2 is lower than 1. In the previous case, beta 2 was rho minus 1, so it was expected to be negative. Here it is expected to be lower than 1. That means that can be positive. Okay. For the rest of the parameter, we expect this similar sign. Okay. So we estimate this equation, which I saw. Again, I was in this slide. I go there.
No, sure.
Okay. Okay. I estimate this equation, and I got, and this is the result. The most relevant result, because as you can notice, again, all the rest of the criteria, sorry, except, sorry, no, this is not, sorry, this is because, let's go here, this one. Okay, all of the rest of the criteria has the similar sign before, but remember that redistribution was expected to be lower than 1. And now we get, okay, according to the model, it's okay, because it is positive, it's lower than 1. It's lower than 1, but it's positive. So now we got a positive correlation between public investment per capita and GDP per capita. Okay, this is interesting because in empirical literature, there is not quite common, but some author have got this result, And they argue that, okay, when we have this positive correlation means that the center, the planner, regional center, whatever, whoever the planner, doesn't care about redistribution. And it's not true. Because, I mean, in general, it's not true. Because, for instance, Castel and Soleoje, in their model, they got a positive role also, a positive role. But they know they are estimating the parameter of social welfare function. And they didn't conclude that the planner is not concerned about redistribution because they know that they are estimating this role. But in general, empirical literature, they don't know. They just are estimating correlations. And when they get this result, they said the government doesn't concern on redistribution. And maybe they are estimating the parameter capturing the risk-averse parameter of the social welfare function. So it's too risky to conclude that, no, this is not, well, maybe they are estimating just this. Okay, the similar parameters are the same. As I said, this important thing here is this. Okay, again, implicit eta is similar to the previous one, about 0.7. Okay, in addition, we propose other variable. This is the public investment that is very common also in economic literature, especially in literature to economic growth. We have this investment as a share of GDP. Again, we write the model, etc., etc. The parameter, the expected sign, we check the sign, and we get again very, let's say, good result according to the model. Okay, and very significant in most cases. Okay. We go further and say, okay, we have also surface. This is not used in the literature, but I say, okay, we have surface. So let's now also propose this dependent variable, the density of investment, public investment density, public investment as divided by the surface. Well, and we estimate again. The expected sign are here. Okay. And we still provide the result. Again, very let's say, well result according to the size expected by the model, significant in most cases, etc., etc. These are the result assuming different coefficient for the efficiency criteria, because according to the model, I didn't say that because it was not convenient for me to say that because it's a lot of time to explain this. But in the model, you can notice that in beta 1J, it's not just beta 1, so beta 1J. I estimate at the beginning just beta 1, common for all the region, and here I provide evidence for separating different coefficients for all the regions. Results are very similar, okay, except for the convergence criteria that in this case is no significant, okay. Well, this is just information. Our idea is just to, as I said, propose a model, theoretical model, to bridge empirical theoretical literature to get our dependent variable as a function of this criteria and estimate. But it's true that in econometrics they say, oh, why don't you control for political variable? Okay. My model is political variables are not included. Okay? But remember that we have the variable VT. This variable VT is a commodity. You can introduce whatever you want, whatever you want it. So, introducing, for instance, in VT, dummy variable for partisan alignment, electoral processes, etc. Okay? We introduced a political variable. We also introduced decentralization variable. In Spain, it's very important to account for decentralization. Okay, we also introduced variables accounting for decentralization, tax autonomy, financial autonomy, for instance. And the results in general for our variables of interest are very similar. I mean, for the criteria, the results are very similar. So the model is very robust, even if we introduce additional control variables.
And I think
Okay.
that's- oh, perfect timing.
Yeah, it's over. Well, basically, the model, as I said, theoretical model to bridge empirical and theoretical literature so that we can get a tractable equation that collecting the main economic criteria suggested by the empirical literature and to estimate and to test the hypothesis about the sign of the coefficients, okay? And interestingly, for us, one of the most interesting results is the fact of introducing output density in the social welfare function and to show evidence that output density should not be overlooked in this kind of problem of distribution. When we distribute public investment across jurisdictions. Thank you so much for your attention.
Thank you very much, Henry. I think we can have maybe like a very short, small question, if there is any from the audience, because we are already slightly, I think, over time.
Could you, Henry, give an intuition of how to introduce the taxation system in the welfare function? So, in the sense that this is, so your title is a general model, but it's not a general equilibrium model.
No, exactly.
So, are any possibility with our
Yes, we think, yes, because this is what, remember that I said that the exogenous constraint, the summatory of the investment allocated to each region must be equal to an amount. This constant amount in that part should be what you said. This tax system, because this is the constraint. Okay, this is the constraint. So yes, this is an expansion, but then that means that we have to deal with this maybe a more general equilibrium model. This is general in the sense that okay, let me just bridge this, not to estimate. Okay, let me estimate this equation. Okay, it's nice, but it doesn't depart from any theoretical model. This is the word general. I also told you that this is the title is ambitious, very ambitious, general. No? It's like, the idea is just that. Okay, but it's true. This is another story about introducing endogeneity, basically, of taxation.
Yeah.
Mm-hmm. Interesting in the case of.
I think it could be interesting.
And the other, as you said, they're considering the simultaneity of the decision of the central investment, regional investment, because this is the next step. This is the one that you said is maybe this is very long for me, but the next step will be considered the simultaneity allocation of public investment across between agents.
Mm-hmm. Nice paper.
Yeah. I enjoyed a lot writing the paper.
Any other questions or comments on? So perfect. I think we can. Yeah, perfect. Thank you so much for coming to the seminar.
Thank you.